I think we can get started now. Settle down. So good afternoon, everybody. Oh, I got to remember that people joining online. So good day if you're joining us online. Let me just start with two housekeeping announcements before I introduce our speaker today. So next week, we are having the distinguished speaker in global development who is going to be speaking during the same time. We are changing the venue, because of the nature of that talk, and it's going to be in 401 Warren Hall. We also have a little bit more time before and after the seminar for people to come and interact and network. So the room is going to be available from noon up to 2 o'clock. The point of that distinguished speaker series is to allow a little bit more interaction between students, faculty, and staff. So please come early. There might be a little bit better snacks than what we have here today. So please come in and come in early and also get the word out. We're going to send an announcement soon. So please do invite your friends and family and your colleagues. The second announcement is that since the speaker of today's seminar series is here in the flesh today, he's going to be available to have lunch with students, faculty, and staff. If you're interested, please do sign up to here. Jenna is up here in the front. At the end, please just come up here and say that you're interested. Or if you have sent an email, just come to us and the lunch is going to be immediately following this event, just down here in Man Cafe. So with that, it is my distinct honor to introduce again our speaker for today, Professor Jesus Orozco, who is the curator of the insect collection at the Zamorano University in Honduras. I'm trying not to get in the habit of reading bios because you have them in front of you already, and I know you'd rather hear from the speaker than you would from me. But suffice it to say, he's had a very distinguished career in this space. He's going to be talking to us on the subject of fighting malnutrition and poor residue management using a wonderful insect that I'm yet to learn about. And he's done amazing work in South Africa, in Tanzania, and in South America. And his work speaks for himself. So you can look that up on his bio. And without further ado, Professor Orozco, you have the floor. Thanks.
Can you hear me well? I'm softly spoken, so I don't know if this microphone is working or. Can you hear me?
Yeah.
Okay. Yeah. Oh, thanks for coming to my seminar. It's a pleasure always to talk about insects and insects related to development. And I'm a systematist by training. I do taxonomy. I got involved in this field about 4 years ago, thanks to a student. So we can, as professors, change your lives as students. You can also change ours. So, and this took a really nice trip, at least for me. First, let me talk about Zamorano. Zamorano is the institution where I work now in Honduras. I'm Colombian. And Zamorano is a co-ed institution, and it's also a boarding school. Students live on campus. It's a very large piece of land, about 10,000 acres. That's about 10,000 football fields. I know I have to make the comparison with football fields. And so far this year, we're turning 80. And from those almost 80 years, Zamorano has graduated close to 9,000 students. So it's an important institution in Central America, doing a lot of research related to agriculture. And 50% of the time the students spend in Zamorano is formal class in the classroom, and the other 50% is working in the field. It's not always in the field. Zamorano's got something called learning production units, which means plants where we produce yogurt, cheese, milk, a bunch of stuff, right? And the students get to work in this. The students get the opportunity to participate, not to work, in these production units, right? And we call the students in Zamorano maquinitas azules, right? Which is the little blue machines, and they do everything, right? So there's 4 departments in Zamorano. Agronomy is the department where I work in. And these all come So Honduras, despite being in Latin America or being a Latin American country, is facing all these problems of overpopulation. It's not as overpopulated as other places in Latin America, but still is suffering from these too many people, not enough food, right? And this problem of too many people started maybe 300 years ago, maybe 400 years ago, but the last century suffered an explosion. And that's a huge deal on how that affects the environment. So in order to produce food, we need not only the resources, but we also need the money. And this is going to have an impact on water and soil use. Unfortunately, and the reason I have a cow up there is steak is very popular. And steak in the movies, when somebody's going to treat themselves up to a good meal, a steak is the one portrayed in that plate, right? And producing cows and producing meat from steak, it's very expensive. In order to produce 1 kilogram of beef, about 15,000 liters of water are used and 6.5 kilograms of crop. That's a lot, just for 1 kilogram of beef. 330 square meters of ground are needed, and 16.4 kilograms of carbon dioxide are produced in order to produce 1 kilogram of that juicy steak, which we all love. Not we all, but some people love so much, right? The other meats are also expensive to produce, beef being the most expensive, pork a little bit below, and chicken requiring less resources than both beef and pork. The two most popular resources for feeding these animals are soy and fish meal. Soy is not a problem by itself. It's a good plant, right? The problem is how we use it. We have to plant lots of hectares, thousands of hectares in order to produce the soy needed to feed these animals. And of course, having a single plant planted for a piece of land brings problems to diversity. It's reducing diversity, increasing the opportunities for pests to appear. The other one is fish meal, and fish meal is a bigger issue, I would say. Maybe if considering most of the surface on this planet is water, fish meal comes from sometimes pieces of fish that are not used, but sometimes also from fish bycatch, that is called, and that ends up being powder that is being fed to these animals. So every time you enjoy a piece of steak, chicken or pork, take into account, is that took some resources to get to your plate. So it's always good to keep in mind, the social responsibility we have with these things. And not to be dramatic, but it's got consequences, right? Two-thirds of the Amazon forest that have disappeared because of cattle. Just in order to put nice pieces of steak on your plate, on our plate, and of course it's a demand thing, right? In order for this to keep happening, people have to keep on asking for more steak. Diversity is a huge issue for soy also. Forest is being cut for soy to be planted, and you got climate change and desertification. There are real things. I'm not imagining nothing of this, right? And we see it in Latin America is in our face all the time. Okay, so this connects to my talk right away. I'm just doing a little bit of an introduction. We have too much food sometimes, right? We talk about waste and people suffering from starvation and malnutrition. But in the United States, for example, 30 to 40% of the food served on a plate is wasted. That's a big number. And around 133 billion kilotons or tons, I think tons. I'll check on that then, of waste is produced yearly. And that's waste that is not being always used as we could, right? We have that problem in Latin America. Is pretty much the same, right? The higher you go in the social scale, the more luxuries you want to give yourself, and leaving a little bit of food in your plate is posh, right? You didn't finish everything. You didn't have to. You're not that hungry. And also at the industrial level, there are problems with waste. And the reason I posted these two pictures here is because they come from two very nice beverages we like to consume, right? The first one, coffee, right? Coffee is a huge contaminant. A lot of the waste that is produced by getting the beans is normally not taken care of. It's just thrown in the soil, and the soils become acidic, and it's hard also. It's a hard residue to take care of. And the other one is from the production of beer, right? Beer is very popular among some people, and it produces this spent grain, which is being used for several things, but still, there's vast amounts of these two residues at the industrial level, right? So insects, okay. We've been using insects since we are humans, pretty much, right? We get honey from honeybees, and then we learn that we can produce nice fabrics to cover ourselves, and then we exploited a little moth, and we got silk. And more recently, we have this carmine dye, which gives a nice red color. But as a species in general, insects are fundamental for our existence. And that one in the corner, those are dung beetles. And if dung beetles didn't exist, we'll be covering poop, right? Diseases will spread. It would be very, very hard for us to survive if dung beetles didn't exist. These little things that take care of the excrements, right? And right now, even the cattle ranches are importing dung beetles, and Australia had to import dung beetles because cows were not originally from the Australian continent, right? So they have to import dung beetles to take care of the excrements. And more recently, in the last 40 years, maybe 50 years, let's say 60, biological control became very, very important for agriculture. And biological control means one animal taking care of another animal. In that another animal is something, a species that is causing us some damage. So ladybirds are popular, or lady beetles are popular for killing aphids, whitefly, and a bunch of pests. But the most important biological controllers are wasps, right? Small wasps are the success, and they're very abundant species. And there's a world-renowned specialist of biological control in San Morano. We're lucky enough. So using insects and insects being so important make us think, why don't we use them to solve these problems of malnutrition and misuse of waste, or we're not taking advantage of the waste we're producing? And it's not a new idea, right? Some people thought about it in the past, and there's a bunch of species being used for both producing protein and not so much for waste recycling. And these are some of the popular choices for producing protein. That's the common house fly, and there's the mealworm, and there's crickets, and there's another cricket here. And there, of course, in some cultures, eating insects is normal, right? In the West, not so much. And this is the insect I'm going to be talking to you about. It's so popular that it's already in the market, right? And the biggest money for the people doing this is for the people that have pets, because pets became part of the family, right? It's not just the company, it's not just an animal, it's part of the family. So people spend a lot of money buying this kind of stuff for, their pets. And those pets can be exotic pets like lizards or whatever, or cats or dogs, stuff that normal people like, right? No, I like insects, right? So, and it's hard to pronounce this word. Entomophagy is eating insects, and this is where society needs to move. This is the solution to a bunch of problems we have, right? And as I said, many parts of the world is normal. My home country, Colombia, there's a little region up in the north that we eat those things called hormigas culonas, which is ants with a big butt. And they're delicious. They taste like shrimp, for real. And they're expensive. They're exotic. But the young people don't like it so much anymore, right? The popular thing is the hamburgers and the pizza, stuff like that, right? And that's what is portrayed on TV. And that's why people moves in that direction and stop, forgetting about the roots. And these are chapulines, which I anticipate these are going to become very, very popular soon in the States because Mexico has done a lot on that front. And chapulines are grasshoppers, and those are also delicious. And as I said, in Mexico is the king on eating insects. Eat more bugs, right? But yeah, okay. The solution is, or the take-home message today, I'm not going to freak you out. It's not you have to go outside and eat insects, right? The solution. Right? If you really love your planet, stop eating beef and eat insects. That's not the take-home message, right? But it's how we use the information we have to produce protein. So we're not going to make people eat the insects. We're going to make the animals we eat the insects. In that way, we don't have to stop eating the steak. In that way, we don't have to stop eating that nice piece of chicken. And we can feed more people for less money, assuming, it will be cheaper to produce. And also there's another things that this special insect that is Hermetia or the black soldier flies got to offer. Okay, so this is the black soldier fly, Hermetia illucens. Black soldier because it belongs to a family called Stratiumidae, and that's the name that some people thought it was the common English name. And English names are useful, but outside of the English speaking world, they have no much meaning. So my students love to call it the Mosca Soldado Negra, and I say, no, please don't do it. It doesn't mean anything to us, right? So the common Spanish name is Mosca guarera. Okay, guarera means it likes guaro, and guaro is spirits, heavy alcohol, and it's because they like. It's a better name, isn't it? And they like fermented fruit, right? So it's attracted to fermented fruit, and hence guarera likes the guaro. So the black soldier flies got a complete metamorphosis, and I'm going to remind you a little bit of your biology, or if you don't know it, I'm going to tell you about it. Complete metamorphosis means it's got a pupal stage, which is right here. So what comes out of the egg is a larva, and the larva doesn't look anything like the adult. The adult is the fly, and it's right there, right? And the larva goes through certain periods of development, and small larva becomes bigger and bigger and bigger and bigger. And at the end, we get that beautiful fly right there. It's got beautiful, beautiful eyes. And okay, so what's special about this thing? Okay, let me go back maybe here. In terms of rearing and the things we can use with this fly, and this is very important in comparison with the other insects I talked to you about. The adult doesn't eat anything. It doesn't feed on anything. So for laboratory conditions, that makes things ideal because you only have to worry about feeding the larvae, right? Adults don't eat anything. They accumulate enough energy during the maggot period just to be grown-ups and reproduce and have babies, and that's all they need to do, right? And they live for very short periods of time, 16 days, and they need 4 days to mature. And the other nice thing about this species is the larvae are voracious feeders of pretty much anything that is organic and decomposing, and of that we have a lot, right? So these are, first 3 pictures are dining hall waste from Zamorano. You know, lots of avocado, lots of beans, lots of rice, all the good stuff, right? That's coffee pulp, right? It's good, isn't it? It is good. Here, this is not from Zamorano, but just to illustrate certain places where they have pigs, the accumulation of pig manure is a big problem, and this fly also can feed on pig manure. That's the fly again. The adult doesn't feed on anything, doesn't need to be fed, and those little things are the eggs. And the other advantage of raising this or having a little farm of Hermetia, if you have a farm, you can do this. It's pretty easy. Is that they don't lay the eggs directly on the substrate, on the organic matter you offer them to feed on. They lay the eggs on whatever is above that's got really small cracks, and they lay the eggs there, and that makes things easy for rearing because you don't have to look for the eggs in whatever you are offering to them, which other species, that's the case in other species, right? So you simply take this off and then you take that to the lab and do all you have to do. And these are eggs, these pictures are from 4 years ago when we started rearing the species, and we're so happy we're able to produce eggs and the small larvae and, little larvae and then more bigger larvae. And as I said, and I will talk to you more about this at the end of the talk. Hermetia is good for producing protein. It's good for decomposing residues, but it's also good for creating a fertilizer that actually in Zamorano we started to use this year. We're doing still a test with how to use it. And those are these little balls, and that's in entomology lingo is called frass, which is poop. Yeah? Insect poop. And these are bigger larvae. And this is that frass. This is what it's at the end of the animals eating all that juicy leftovers that the ungrateful students didn't want to eat. We end up with this, right? We have 2 students here from Zamorano. So this is a little graph that shows how other people employ Hermetia, right? So as I said, this is from Gracious fruit, and they feed the maggots with larvae, and then the cycle is there, and they use the waste as a fertilizer, the fertilizer, and then they feed the larvae to whatever animal they have. So we've been wanting to do something like this in Zamorano. That's been the purpose, right? If somebody else did it, I can do it. Even if I'm a systematist and never reared an insect in my life. And this is another example of just a different use. These people is more focused on producing biodiesel, which is that would be a different talk by itself, but it's also very popular. And actually, there's more money in producing the biodiesel and producing this oil than it is in producing the meal, the Hermetia flour. And we're moving in this direction this year. We ordered a press in order to be able to extract that oil and see how good is that oil to feed cows. So this is Zamorano. Now we have a protocol. Now we're doing it, and I'm proud to show this. It's supposed to be out this year. We've been thinking how to do this publication. We already have always thinking in academia, right? More papers get a bigger job, bigger university. I'm past that. I wanna reach people. So we decided we're gonna do it like a booklet, and we're doing it in Spanish. Right? Sorry about that. That's gonna kill my career, right? Not many people is gonna be able to read it. But it's going to impact the region, and that's where we want to get. So we have this protocol where we now know how to produce these insects in the house, and we feed them with dining hall waste. We have a whole system how to do it. We use 2 grams of eggs. That's another source of income. We're thinking about exploiting maybe in the future, because this is becoming more and more popular. And probably for many of you, hearing BSF wasn't the first time you heard it in the past, and it's becoming very popular. And people want to start. And we started with just one female laying eggs, and we built a column from just that one female. So people can't start like that. So we can sell them the eggs, and 10,000 eggs, and you can start right away. So that's the source of income we're thinking about exploiting in the future. Okay, regarding animals, what have we learned, or what have we done so far? When we feed little chicks with Hermetia, nothing happens. There's no effect on their growth. There's no effect on their behavior. Nothing. When we've done all the experiments or the tests you can imagine, nothing happens. The only thing that happens is that we're saving money on buying the feed for the animals, right? And we're utilizing the waste that the dining hall is producing, right? You have to teach them, right? You have to teach them. And there are different races, and apparently there are some rustic races that are more prone to eating maggots, and there are some that are more, they don't like the maggots so much. And this is again, this is another protocol, and I'm showing you these protocols because this is the real bottleneck. There's a lot of literature out there on Hermetia. You can find lots of information. There's a lot of YouTube videos, but nobody tells you how to do it. Nobody tells you what's the size of the container you have to use. Nobody tells you how many eggs you have to put. And that's the bottleneck. And that's what we feel is useful. So it's not hard science in the sense of putting a protocol out, but it's going to help a lot of people. And the hard science paper will come from the other part of this talk, which is how the diets affect the animals. And that's a whole different game. And that's not my specialty, so I will be careful with that. So how we do it normally, so we collect the maggots, nice and juicy. Some students have tried them raw. They said they taste delicious, and they have to say that. And we also roast them. So, and then we put it in the freezer, and that kills everything. And we've done all the tests, because we're gonna feed these two animals. We have to make sure it's not gonna make the animals sick. Then we dry the larvae, and we try different procedures to dry them, and then we grind them, and then we produce this meal. And this is very difficult. At least for me, as I said, I'm a systematist. I never done it. I think of dead bugs in a museum. So that's what took me the most time learning how to do it. The ideal thing for me to do would be just give this to the producer, give this to the guy with the farm, because producing this for me at this point, it's easy. But grinding them and making this meal is difficult. But of course, for the people that's got the animals, they want the meal that they can put in sacks, and they can decide when to feed it and how to feed it, and if they want to mix them with the feed they have. And we have this protocol already working, and as I said, we're using some of that frass to fertilize lettuce. Lettuce is one of the important crops for Zamorano. All our lettuce is bought from Walmart. There's a Walmart in Honduras. Yeah, we have Walmart, and so there's some pressure to produce our lettuce, and fertilizer is very expensive. There was something called the container, how's it called? The container crisis, with some containers were stopped, and the fertilizer was in those containers, and that was because of the Ukraine-Russia war, and people didn't have fertilizer for their crops, and we had this. And I was wasting it. I was throwing it away. So now we're doing some studies in order to prove the Hermetia frass or the black soldier fly is as good as the fertilizer you buy for your crops. Okay. This is the drying method we use for the maggots. So these are the maggots that came out of the freezer. Those maggots did not suffer. Insects don't have nociceptors. They don't feel pain. Plus, we put it in the freezer, right? So they fall asleep, And that's important because in order to produce cattle and all those animals, they do suffer. They do suffer. You have to see chicken in those cages and then try to eat a chicken the same day. Not easy, not easy. And that's been revealing for me. So this is how we dry, and this is a solar dryer. And in Honduras, this is being used by the people that is planting coffee. Very effective, and we can put here 200 kilograms of larvae, and they will be dry in 5 days, depending on the temperature, right? And these are our current numbers, and I'm proud of these numbers. These are hard numbers, and we're limited by this. This is the amount of organic waste we're receiving our unit. So 150 kilograms of tiny whole waste. That's what the students don't eat, which is around 4 tons a month. And from those 150 kilograms a day, we have 7.5 kilograms of fertilizer, 20 kilograms of fresh larvae, these migratory larvae that I will explain later. A meal, 8 kilograms of meal a day, that's a lot. It doesn't cost much. And 10 grams of eggs, which is, we are planning to sell in the future. Not many people is needed. Right now, it's a team of 4 with me, a supervisor, and 2 people in the field. And this is the meal at the end. And these migratory larvae are the larvae that is going to become flies later on. We're going to be needed to maintain the colony. And these are good numbers. This is what people people that, my customers, right? The people that need the product, or this is what I need to show to the people producing the chicken and the pigs and the other animals, how good my product is. 36 protein, that's a lot of protein. That's lots and lots and lots of protein. And people frequently focus on this protein, but there's a lot of good fats also. And fats are very important for fish. And there's a very distinguished professor in San Morano that works with chickens. And he tells me that we can feed Hermetia a certain thing that then he's gonna get in his eggs and in the eggs we will sell in the future. So I think he's thinking about omega something, and that's important, right? This is how we compare. This is us and how we compare to what little is published in the literature, because this is like a recipe where people don't want to disclose their data, right? We compare very well. Even we're above some of those numbers, and we're just starting, right? And just 2 years ago, we got some funding. We've been doing it just with the little money we get from each student to do the research project. Students, as part of their program in San Morano, they have to do a research project, a little thesis. And there's a little money that comes with that thesis that the professor administrates, and that's how we started doing this. And sorry, I didn't translate all these long names, but very similar in English, very, very similar. This is that fatty acid composition, which is so important for so many animals. Okay, so regarding the part with animals and how these things impact their diets, this is something that we started doing 2 years ago. And when we started with the whole Hermetia project or the black soldier fly project, everybody wanted us to tell them right away if it was good for the animals or not, but we were not ready because we're just building that protocol on how to mass produce the larvae. And in general, what we've been doing is feeding different animals with different levels of inclusion of Hermetia meal in the diet, right? So normally we have a controlled diet, which is the normal diet the animal gets. Then we get a 15% inclusion, right? So not 50% of black soldier fly meal added to the diet, but 15% of the normal protein they get extracted and Hermetia protein put in their diet, right? And the same with the 20% and the same with the 25%. Right away, this means if any of this works, people will be saving 15% in protein from the other feed they buy, or 20 or 25%. And there are lots of advantages which I don't have to talk about, but Hermetia doesn't only afford or provides protein. It's being shown that makes the immune system of the animal stronger. So there have been some tests showing the chickens fed with Hermetia meal are better at surviving salmonella attacks. So there's a lot of stuff, which is very good. And this is some of the trials we run with hens. And what I can tell you again, with the chicks, no difference. Nothing negative except saving on feed and bigger eggs. So we're getting bigger eggs. And again, this professor in Zamorano is so excited about this. And there's a master student just finishing. And where we want to go with this is produce organic eggs. There's no organic eggs being produced in Zamorano till now. Okay. Same thing with tilapia. Results, no difference, right? And this is the highest we've gone with tilapia. There's some literature that say up to 60% show no difference with tilapia, and we want to go there. There's a huge shrimp industry in Honduras that will be excited about getting Hermetia from us, but our limitation is the amount of waste we're getting a day. We're getting 150 kilograms, and that's our bottleneck in order to get out of Zamorano, right? We did also a small experiment with these pigs, right? Nice, beautiful, fat mummies with their little piglets. And we fed the mama, the big mama, we fed the Hermetia to see if there was any difference in the milk, any difference in the piglets. You think? No difference, right? So Hermetia, good for all these things, saving money. And this is the latest thing we've been doing. We've only done 2 tests with this, and it's using Hermetia as a fertilizer. With lettuce again, and this we did it replacing entirely the normal fertilizer, which is urea, uric acid, and replacing it with different amounts of Hermetia, and again, no difference. So the future is there, easy to do. Once you have the knowledge, we're going to put it out there for everybody to start. And this is the last part, waste management, right? This is coffee, or coffee pulp, and these are different levels of inclusion, 20, 40, 60, and 80% of coffee pulp, and it's got some effects on the biology of the species. Hermetia doesn't like coffee pulp that much. It's very acidic, so you have to help it with something else. But we're working on it, and the reason we did it is because coffee is popular, and coffee is a huge contaminant. And there's one single paper that we want to test if what they found it's true. So you can see in the mobility there's some impact. The more coffee pulp you get, the less they move. Right, compared them with the control, which is the dining hall waste. So you can use them for waste management, but you have to keep in mind those things cannot be used to keep your colony, because also at the end we only did it with 2 generations. This would be very small flies. Nothing wrong with being small, other than a small female will lay less eggs than a bigger female, and we want them to be big to lay more eggs. Finally, these are just something to show you the tests on how Hermetia can decompose different types of material. And we've done experiments with, apart from the dining hall, with cow dung and pig dung, and it works, different things, and affects the species also differently. We're getting around a 15% bioconversion rate. And That's all. That's all I have. I have to show these people's names. Those are all my students through the 4 years, and the first four are my core team and professors that are specialists in their own field that have been helping me on getting this on board. And I hope you found that interesting. I'll be happy to get any questions.
Professor Orozco, I don't know about you, but I'm sold on flex on fly. I will look for that when I go to the Cornell dining next time. So we have time for questions. You can raise your hand and make your question as brief as possible.
I just had one question. I was wondering, so you're saying like the black soldier fly, like anything that's organic and it reproduces and it's incredibly fast, like is there a risk of like contagion, like if the black soldier are like if they're released into the wild and this is being done on a global scale?
Yeah, well, that's something I missed to say, and that's something that is also good for us in the American continent. This is an American species. This is a species that is distributed all the way from Mexico to, I'll say, northern Chile, where still there's some warmth, right? But it's considered now a species that is cosmopolitan, that is worldwide distributed. And the good thing is we only feed on decomposing matter, and there's nothing that is decomposing that really is interesting for us. So it's not going to compete with us for any resource. The other thing is, for example, here in the States, there are some places producing black soldier fly meal or the larvae. But when the winter comes, the whole production stops, right? So you can do it in buildings. It's going to increase your costs, but in the sense of becoming a pest, very low risk. Thank you.
Yes, yeah.
Hi.
I'm wondering with your field experiment on fertilizer differences, if that was by volume or by NPK amounts, or how did you test the differences?
Okay, so I show, but we have the composition of the frass, right? So we know how much nitrogen is the frass apporting to the plant, etc. So what we did was take off the normal fertilizer and try different amounts of the Hermetia dissolved in water. So what we did was dissolve different amounts and then apply with a pump and see how that affected the height of the plant, the thickness of the trunk, the size of the leaves, the number of leaves, how many roots, and that kind of stuff. And we found no difference. That was the first experiment we did with that, and there's a lot to be improved. But the reason being, we want to find the right amount of frass we need to put on the plants to get the bigger leaves.
Question? Yes, go ahead.
Thank you for the presentation.
Thank you.
Talking about the risk, but what about or spreading some kind of well, and also it's great for America, but it's also good to Africa and Asia. Right, other ideas about their controlling, great for that. Then other types of insects that might be also.
Yeah, well, I'll go with the second question first, right? The highest amount of research being produced on black soldier fly now comes from Africa. The African countries are doing great on investigating a lot of these things, right? Kenya is taking the lead, Tanzania, South Africa, but there's some other countries getting there, and they have their huge production plants working. China is one of the biggest, probably the biggest in everything, pretty much, right? But that's for profit. And Hermetia can do very well in Africa, and it's not going to cause any damage to the environment, especially taking into account that the adults don't feed on anything. It can compete, right, with a resource with another species that is also a natural decomposer in Africa, but normally those those levels of competition wouldn't affect the species as much. Said that, I don't have the information, I don't have the observations to say it's not going to be able to displace by competition another African decomposer, right? And the first part of the question, that goes back to something I mentioned, that some of the other advantages of the black soldier fly is that it helps the immune system of the animals that is being fed to. And that comes because many people was worried about that, right? You're giving me this larvae, and this larvae fed on waste, on garbage, is going to make my animals sick. And we've done a lot of tests before feeding into the animals, and the levels of E. coli and coliforms and other types of pathogens that can make the animals sick is none. So it's not present. And we did different tests also, seeing if freezing them or boiling them in water, or freezing them and then boiling them, and different tests if that amount of pathogens decreased, and it kept always at a very low level as to not make the animals sick. So yeah, it's pretty good. Yeah.
There's a question online from Professor Rebecca Nelson, who's asking that in Kenya, I think the company is called Synergy, they are using human feces to feed black soldier fly. Have you tried that in the Samarana?
Yeah, we tried with pig feces, and it's very similar. You know, omnivores, stinky poo. Yeah, it's possible. It's possible. You have to be watching on that part of, no having any pathogens being transmitted to the animal you're feeding your larvae to. The biggest problem for us was that pig feces are so stinky because they're so rich in nitrogen that pretty much every other insect wants to be on those feces. So keeping other insects outside of our facilities was very difficult. So we got a lot of contamination. We got other flies laying eggs on those feces. But yeah, it's possible. I mean, if you find a way to isolate your unit, and if you have a lot of pig feces or human feces that and you can make an innocuous at the end, go for it. Yeah, no problem.
Great. Thank you. Go ahead.
Why this particular species? And are there any other species? Instead of taking an exotic species into a different place, can we look for more native species? Because they can have the trust.
Okay, that's it. Okay. Again, I sent that question in two parts, right? The reason I got involved with this is some student's fault. He asked me about this, and I tried to make my students happy. And I said, okay, let's try this. Let's build a colony. And then some people came to visit, and they thought it was interesting. And I tried to kill the project because, it was too much work, and now it's too late, and now I'm giving a talk internationally. So, yeah, so that's how it goes. So be careful the projects you start. You never know where they're gonna end. For us, the black soldier fly is endemic. It's from our region, so we have no reason to worry about that. And in comparison with the other species of insects that people is using to produce protein, this got some advantages. And one of those advantages is that the adult doesn't eat anything. And the other thing is that you don't have to prepare a special diet for the maggots because they will eat anything that is organic. So if you have any other production, if you have chicken, if you have plants or whatever comes from your kitchen, you can feed that to your maggots, and then it will not be as expensive as producing, say, the mealworm. Okay, yeah, great questions. The first, no, we did not. We didn't check the how fertile were the soils before. So, and actually, that's part of the results show that the soils where we didn't apply anything showed the plants did well also. So we have to check on that and have a little bit more control on that experiment, right? What was the second question? Sorry. Okay. Yeah. So how this became popular in Zamorano, at least, was because the United Nations, no, the European Union, was asking for proposals for malnutrition, and I decided to write something related to that. And what I proposed at that moment was building a small biocomposter, something that people could use for their kitchen waste. And there's some drawings, I don't remember the English word, of how you can make one of these for your house on YouTube. And they have the little holes where you can train your chickens to feed on that. And that's the direction where we think maybe somebody else can do it, right? So I can keep working on some other things of the biology of the species that are important, and is how to build these little things so people just throwing their kitchen waste can get eggs from their chickens. And but that's what I proposed 4 years ago, and I was so naive thinking this was going to be easy, and fortunately I didn't get the grant because it would have been a nightmare. Yeah.
Yeah, I think unfortunately we're running out of time. I must say that I think the potential for this area is simply amazing. I tasted once an ice cream made of blood soldier fly larvae in Cape Town, and it was a more delicious together. So it's also very good. So on that note, I'd like